Welcome back to Contextual Electronics. This is part 6 of the Getting to Blinky series, the board layout portion, which is always an exciting time in any project when you actually start doing board layout. We'll be taking those components we brought in as footprints and then connect them all together, putting them on a board outline, and then in the video after that we'll actually output it so that we can send it out to become fabricated. Alright, so let's open up KiCad. We've got, we're going to go straight into the layout. PCBnew should be about where we left it off. Now there's a couple quick things here. These actually white lines here are called rat's nest. That's showing the actual connections that are made in the schematic that are then translated over, telling you where each thing needs to be hooked together with something else. So that's important to know just for as we move forward. So we're going to actually start by creating a outline, and we're going to start with just a really generic, really simple to do 1 inch by 1 inch square board. We define the board just by defining the outline. So we have to make sure we're on the correct layer. This is where all the layers are. We're going to go to the edge cuts layer. Then we're going to pick a level here, just a random spot basically inside the sheet. The sheet is actually of no consequence. The fact that there is a it's mostly for display purposes. You definitely don't want that to go through to your output files from the layout. So we'll just start from a point. We'll hit the space bar to actually normalize to 0 there. You can see that, zero that out. We're going to start by, didn't like that. That's odd. Huh. Edge cuts should be the right layer. I had the lines backwards. This is the trace line, which I got confused with the graphic line. That's the one we want. There we go. So the space bar, click. There we go. Alright, so we're going to take this over to 1 inch. Click. Up to 1 inch this way. You can see you can actually go out until you get to about 45 degrees. You can actually kind of move your mouse around and just kind of dial it in to where you need it to go. Usually if you need more resolution for moving your mouse, you can zoom in. That really helps a lot. At least it helps me a lot. Over here we want to go to minus. Oh, did I miss that? Oh, yeah, there we go. And 1 inch. There it is. And then, oh, no, I must have, shootski. Let's go back one, zoom in, click on the edge here. Huh. That's why. We're going back towards 0. I was thinking the other direction. We're actually going back towards 0 here. So you need to kind of keep that mental math in your head. That should be good now. And then we go down back to 0, 0 in this differential, in that differential area, the dx, dy. Double click, and we're good. Alright, so we have a board outline. Awesome. That's a good thing. Now, the first thing we need to check here is actually that battery holder, because that's by far our biggest component. We need to make sure we can actually fit that on the board. And as expected, we will not be able to fit this on the board, so we need to do one of two things. We either need to increase the board size, or we can try and get tricky, and let's try rotating it. We can go, that's the pad. We actually want to edit the footprint. There we go. And then, so this is the footprint. You can see the value here, the reference. If we go to user defined orientation, we can set it to rotate by 45, and it's in 0.1 degree increments, so we go 450 actually. And that's still too small. So we need to go just a wee bit bigger, or we would need to switch over to a through-hole component so the pads aren't quite as wide. So let's go back on that. We'll let's take this out a little bit. So we can actually center over top of this line. Should be able to hit G for grab. Grab the graphic. Should actually, I did not like that. Alright, so we'll do this the easy way then. Delete that line. We'll start here, we'll zero this out, we'll make this our new 0, and we'll take it out to 0.2 from here. So let's start drawing here. From that 0 point, we'll go over another 200 mils or 0.2 inches. That should be enough. dx, there we go, 0.2. Then we'll go up. That is not enough. We can see that right there. Yeah, let's make it 1.5 just to make it simple. The only downside to doing this kind of thing is that it actually makes our board more expensive. So we need to keep that in mind here. That actually might be detrimental to what we're trying to do here. Definitely don't want it to be too expensive for people, because your first project should not be a very expensive project. Let's see how that fits first. It fits, but it's not. Well, let's do the obvious thing here and switch out the footprint. So we can actually do this directly from the layout. We can mouse over, hit E. We can go to the module editor, and we can actually change the footprint right from here, which is nice. So open up the library. There we go. Then we can change. Well, first we need to actually find a part that fits that. I happen to have that still open here. So we need a through hole one instead of a really wide surface mount. So let's try this one. And there we go. Let's check out his drawing just to see how wide it is. Looks like the 0.83 is about the width here. So that's good. It means the board will actually be narrower, which is what we want. So I guess we should just start changing this footprint around here. So let's zoom in here and start changing these sizes. So if we mouse over this one, hit E. Alright, so we need to change it from a SMD to a through hole, so that's easy. So we need to change it to circular. And then we need to do two things here. First off, we need to change the size of it. And this right here is actually giving us the drill size, so 0.08 inches. So that's going to be our drill size. And then we need to pick a annular ring that's larger than that. Right now it's huge because this is still based on that really big through-hole footprint. But let's pick 140 and see how that looks. Oops, 140. Nice big annular ring there, which is the amount of, landing for your solder. And then we can also put in our position here, which is really nice because it's, if we look here, this is actually all keyed off this 0 center point here. So this is already at 0.510 away from the center point. So we can actually do the same thing here. We see it's 0.85 in either direction, right? So that would be, oops, here would be minus 0.4. Oh, we need to do math. 2.5. Here we go. All right, let's see how that looks. Yeah, a little outside of our circle here, but it's nice, large pad, and yeah, it's keyed to the right position. That looks a little bit too big, actually. Let's take that down a little bit. Take that down to 120. There we go. That's a little better. Okay, so that's good. Let's do this one then. So then this one, same kind of thing. We're going to switch it to a through-hole pad. We're going to change the position to 0.425. Through hole, this is going to be circular. The drill size is 0.8. And our pad was 120 on the other one. 120. Alright. Finally, this pad's a little bit smaller here. The negative contact pad. So let's go ahead and edit this one. And we'll change this to 0.16 and 0.16. Alright, so that's what we look like here. Let's move these over a little bit. I'm not sure if the grab's going to work here, but nah, it doesn't work there. So let's delete this. We'll draw, and we'll just eyeball this. It's no big deal. That's good. Might end up having to redraw the other ones too, but eyeball this. Looks pretty straight. Oops. There. Escape, delete. One more time here. Feel bad. I feel like the drawing portions are the most boring portions to watch, so hopefully you've figured out how to fast forward through that. Double click, escape, delete, double click, and one more up here. And double click. Alright. Oh, and crooked. As anyone in Contextual Electronics beta group will tell you, I am quite anal about seeing crooked lines, so yeah, okay. So we're going to save this. We need to, so now we save the module. That looks good. Okay, and then we close it. And let's actually update the modules here. Alright, so we'll do what we did before. We'll delete this out. Delete the module. We'll reread the netlist. There we go. There's our new shape. Awesome. Nice and fast. Alright, so let's move this into place. See if we can't get that back to the 1 inch that we wanted to start with. It should be right at 0, 0. Oh, that is not 0, 0. Where did we start that drawing from? So we'll set this as 0, 0, or as our differential point. Delete this line. Ah, it saved our line for us. That's nice. And see if we can't delete this one as well. And then draw. Here we go. Awesome. Oop. Got a little bit corner there. All right, there we go. Move. Looks like we should be good to go. Now, the other thing we need to do here. So this is our first footprint that we're placing, right? So the red shows that that's actually the top layer of copper. We can look at that here. Front side copper is red. Or we can also look at it here. Front copper is red. Instead, what we can do is we can hit move. So what we need to do is actually put this on the, we want to put this on the bottom side of the board. We want to put all of the fun stuff, all the chip and the resistors and everything on the top side of the board. So what we do to put on the bottom side is we hit F, and we see that it changes, it flips it to the bottom side of the board. Now you see the pad turn green. The through-hole pads didn't change because those are actually, those are always, you know, they'll show up on the top and the bottom because it's going through the board, through hole. But this allows us to move stuff to the bottom side of the board. We're going to rotate this so it's actually in the same orientation. The battery will actually come in from this direction. Alright, so we'll leave that for now. That looks about good. Let me move it up a little bit to, oops, a little bit to the left. I want to kind of center it. I want to make sure the holes aren't too close to the edge of the board. A little bit left. There we go. Alright, and now we can start moving other components on top of it. So let's actually do a group move. When you select your group here, it actually asks what you want to include in it, because sometimes it'll grab the outline of the board layer, and you don't want to do that. You don't want to include tracks or zones once we actually start routing that stuff. In this case, we're grabbing everything. So move this down here so it's just a little bit closer to the board. You can see all the rat's nests move with it. Now, my general guideline here is I try and move chips first, because I kind of want to place the big important components first. So I'm going to drop this right in the middle. There we go. Now you can see also that we put stuff over top of one another. So the pad is actually on the bottom side of the board. However, that's okay because all of the red pads are on the top side of the board. If we want to just look at top versus bottom, we can actually deselect over here, and it won't actually get rid of all the pad stuff, but we can get rid of some of the pads as well. Get rid of the pads in the back. So if we want to just view the top side versus the bottom side, that's how we do that kind of thing. All right, let's go ahead and move the rest of these components. Now, I'm going to start dragging these around, and we'll actually be able to see some of the connectivity. We actually might also want to split screen this with the schematic, because looking at the connections as you're going along can really help to kind of figure out what should be connected to what. So let's keep it like that. We'll move this over to here. Zoom out a little bit. Oops. Zoom in here a little bit. So it looks like we want R2 and D1 to be near pin 3, which is over here. So we definitely want R2 and D1 over here. That's R2D1, not R2D2. Sorry, terrible joke. So we'll actually mouse over, select the actual footprint, not the references. Move those over here. Same with this. There we go. We want, which one is this? This is R1. We want that to be up by pins 6 and 7. So we'll move that up there. Oop, I grabbed the value by accident. So we can move that up. And then C1 we want to be also by pin 6 and pin 2, so we can put that up above. Up here. Here we go. And the VR wants to be up above the rest of those things, so the VR wants to be up by pin 7. So we'll be able to put that over here. All right, that's a good start. Good start, good start. So let's start flipping this stuff around so that it makes more sense. You move here. Now, as you start getting more stuff over top of one another, it's going to ask you more specifically about what you want to move. So we want to rotate that. We want to try and get the rat's nest as clean as possible before we actually start moving stuff around like that. Let's see, pin 5 is going to be unhooked up. Pin 8 is VCC, so we want to be able to, that one might be tricky. Let's actually move this guy up. One. There we go. That's going to be a tricky one. All right, we'll get back to that. So we see VCC actually wants to be on pin 8, and then we want, or sorry, pin 4. Did I set that as the wrong pin? Oh no, okay, so pin 4 and pin out 8 are both connected to VCC. We'll take care of those in a second. And then pin 1 wants to be connected to ground. So let's see how we can do this. Well, let's get these in place as well. So pin 2, R2 rather. Yeah. Move the footprint. There we go. And this we'll actually put right down below. Yep. D1. Put it right down there. Alright, so that's good. Looks like our parts are pretty much in place. Now we want to do something a little bit different. So that's ground. That one's pin 2. Pin 2 and pin 6. So let's go ahead and move this like that. Okay, that's a good start. All right, so you can see we have a lot of room here, which is, a blessing and a curse, right? It feels like we should do more with it, but we don't necessarily have to. So let's move this one down a little bit. So let's actually start routing some of these lines. So if we hit the add tracks, we can also do that by, we can make this bigger now. Oop. Come on, wrong side of the screen. There we go. Let's, we can also mouse over and hit the X key. That'll start a trace. Oop, it should start a trace. We're on the wrong layer here. We need to select copper. And X. There we go. Okay, so it's defaulting this. You can see the track width is at 10 mils. Any via that we drop, which is a hole down through the board, which actually connects the top layer to the bottom layer, an actual trace, will be 35 mils. So we can actually show that if we start a trace and then we hit the V key, it'll create a via. But then now you see that the trace is the bottom side of the board. All right, so let's, if we hit V again, if we're actually not drawing, we can actually hit V again to switch from, if you watch up here, switch V from top side to bottom side. Then we can connect up. And then there we go. We've connected our first pad to our first 2 pads. Now we can keep going. We're already in the via drawing or the trace drawing tool, so we can just click and go. Let me undo that real quick. You can see as I click and draw that there's actually there's thinner lines on the outside, and what those are is actually clearance lines, so that if you cross a thin line with a pad or another trace, it's actually not, you can see I'm actually, it will not let you draw it that close. You can click, it's actually not going to let you draw it though. And that's a great feature because, especially as you start getting more components on board, you might want to make sure that you're not running into problems. We'll actually do a check later with ERC, where we should, or DRC rather, where the design rules checking actually shows the spacing that we want. All right, double click there, hit escape, try it one more time, and click. There we go. All right, so we're going to leave that ground one unconnected. Well, actually, that's kind of hard to see right there. What we're going to do is actually click here, run that down through the middle here. Well, let's do this one first, and then this one up in that same branch. Then we'll connect this one up here. You see we're getting, everything is pretty simple right now, simply because of the spacing that we have available to us. Well, this is probably our tightest fit there. We can make that connection. There we go. And then finally this connection here. Now, we actually did not connect up any of the grounds or the VCCs. You might be asking why did we do that? Well, there's another thing that you can do with layout where you create a pour, which is it basically fills in all of the empty regions in your copper layer to connect anything that you'd like it to. So in this case, we're going to select the filled zones, right? We're going to draw here. We're going to draw it on the outside. So we're going to do the top layer of copper. We're going to actually select the net name, so it'll connect anything that has this net name, VCC, it'll connect it all together. And then we can start actually drawing this on the outline here. So we draw the outline of this, connect it all together, and almost done. We double click to finish. You see that there's a outline there. If we right click, we say fill, you can see it auto fills that entire region. Now, for the pins that match, it actually creates these thermal vias here, and it actually connects those together. It does the same thing down here. Pin 4, if you'll remember, and pin 8 both wanted to be connected to to VCC. That is not a great connection. Now, the only way that this is actually connecting is through this VR1. I'm actually probably going to redraw this, just because that is not the best of situations. Really, layout is kind of like a puzzle. You want to make sure that you're, you shouldn't feel afraid to redo things. So we right-click, say remove filled zones, so we can actually keep the filled zone, but then we can remove some of these traces. If we mouse over a trace and hit delete, oops, get out of that tool, hit delete, we should be able to delete the track. If we just hit backspace, we should be able to just delete segments of the track. See how that kept it around? I actually want to get rid of the entire track though. Track, there we go. Alright, so how can we do this a little bit better? We want pin 2 to be connected to pin 6 and pin 1 to be connected to pin 7, but we want pin 8 to be more available here. I think what we should do, yes, so what we're going to do is actually delete this one as well. Delete the track, delete this track, and we're actually going to move this entire one down. And we'll move, we'll delete this track. You can see I'm doing quite a bit of tear up here, but that's okay. Move this one. There we go. Then we'll be able to move this one. Oh, let's delete this one as well. Delete. And sometimes you don't actually figure these things out until you're kind of deep into the testing. You don't know necessarily what you want to get done here. Let's go ahead and move this again. All right. And we'll be able to move this. Just to make sure, let's actually keep... So we actually don't want, now that I think about the battery on the bottom side, we actually don't want the variable resistor to touch any of the bottom of the resistor or the metal casing there. So let's just make sure by keeping it outside this outline here. So we'll move this, rotate it. And there we go. All right, let's wire this up now. So if we go back into the wire mode X, we should actually have a little bit more freedom here now. Good. We want pin 6 also connected here. And finally, we want pin 1 to be connected into that. Now, I'm sure that some of you are staring at this and saying, oh, you know, why don't you just tee it into there? It's just, you know, my style. I don't really like teeing stuff in. It's not the worst thing. We're not doing anything crazy here, so signal integrity doesn't matter at all. So it's just a matter of getting it all hooked together. All right, and then we need to hook up this one as well. And there we go. All right, so we have, let's see, we have everything hooked up mostly. If we go back, if we want to fill this back in now, click on the filled zone again, right click inside the filled zone and fill it back up. And we can see pin 8 is now hooked up much better. Now the thing that is not figured out yet, oh, I forgot one here. Oops. Hit X, connect this together. And then if we right click, we'll actually see it do that calculation outside of that trace we just drew. All right, so what is missing here is the ground connection. So we need to do two things. One, first we need to draw a ground plane on the back side. So let's actually make it easier to see by getting rid of all the top copper. Then if we go to backside copper, we draw another filled zone, and it's going to ask us what we want to actually associate it with. Okay, backside copper, we're going to select that net. We're going to create here, there we go. Click, and finally double click, right click, and fill zones. Now you can see it connected at this big ground pad here, so it looks like it's going to be all copper, and it is in the actual copper layer. It's going to look like all copper. However, the only thing that's going to be exposed is actually right here on the ground pad. That's the only thing that will actually be showing through. So when you want to connect up a battery, it'll actually touch there. It'll touch that copper. All right, now the final thing we need to do is to actually connect up, oops, wrong thing. Go back to the drawing vias. So we want to hit V, so we go to the top layer copper. We need to connect the top side pad here, pin 1, to somewhere in the ground plane. Now we don't actually need to connect it to here, even though it's close, we could. Instead, what we can do is we can just draw a trace. Oh, that's terrible to look at. Let's get rid of the bottom side. Turn on the top side again. So we can draw a trace. We can hit V to drop a via. We can double click, and it should... Oh, let's get rid of that. That didn't show very well either. So we'll remove the filled zone. So we're going to click. Oh, wrong side again. There we go. We'll click. We're going to chop a via and double click. And there we go. So now it still shows this rat's nest here, but it's actually connected down to that bottom layer through this via. So if we then generate the top side copper, fill a refill, we turn on the bottom side viewing, we fill a refill. Let's turn off the top side there. We see that this via layer actually connects to this copper, which is all over the board here. So anytime we drop a via to the bottom side, and it's labeled as such, then it will it'll show up as connected, and that'll actually make that connection. So we can do the same thing over here. So let's do that. Let's get rid of the show here. Turn the copper layer back on. We want to draw a via. These two can share a via, actually, which is nice. Oh, wrong layer. We can drop a via here. Oh, shoot. Let's undo that. Draw V, double click, and then from here we can connect to the same. Double click. All right, and these two are now connected to the ground layer. So let's turn on all of this, fill in all these zones. Oops, right click, fill zones. And now we look down here. This is all of the other data points about this board. We can see there's 21 pads, 2 vias, 31 track segments, 20 nodes, 7 nets, 14 links, 14 connections, and most importantly, 0 unconnected nets. That is actually quite important here because that actually indicates there's no rat's nest left to connect, and we have completed our task, at least for the layout. Now, let's save real quick. Okay, and let's talk about the solder mask, which is the white or yellow or whatever color you want. It's basically the legend that goes on top of on your board, right? So we can actually look at, we can tell which components are which when we're just staring at the PCB. So on the top side here, it's going to show up as, we're going to see 755 and the U1. Here we're going to have C1. So if we can actually move certain things in here, we can select just the reference. So we can move that down here. Now if you can, it's kind of hard to see, but you can see these are slightly different shaded. If we actually hit E over top of the value, we see that it's actually invisible, which is how I prefer to do it. So we're going to leave that as invisible. You could put that on your board, but I think that's kind of hasty to do. In this case, both of these look like they're both visible, so we're just going to keep D1. Let's move that over a little bit. Let's move that here. For the LED, we're going to select that, make that invisible. Same thing here, we're going to move the silk screen out just for ease of viewing. Oops. And we want to move this out because once you actually place a component there, if it's covering up the silk screen, and you say, I wonder if this is R2, but the silk screen's underneath the actual component. Same thing for here, we'll actually move these around. So value, we can keep the 755 the 5 there. Move this down, reference, move that over here. That's interesting. Okay, so most footprints usually have an indication. Oh, I guess this one does. Yeah, so usually they have an indication of where pin 1 is. Sometimes they'll have a dot by pin 1. On ICs, though, as well, they have this marker here. It's kind of hard to see with the green. If we turn that off, we can see it. We turn off the back pads. There we go. So we can see that actually indicates the top side of the component. I think we're going to make that invisible as well. Oops. E, value, invisible. And then we'll move this R1 up. R1, oh, shoot. Move value, or reference rather. Battery, we're going to make that invisible. Invisible. I think we can figure out where the battery holder is. And then finally, this is outside the board, so this is very important to pay attention to. We're going to move this inside here, VR1. LDR shouldn't show up. We can make sure that is actually invisible. It is, so we'll just move it for good measure. Okay. Now, some of these others look like they might show up, like this VCC. That's actually the labeling of the net name, but that's not going to show up actually either. I'm not sure about this blue circle here. We can tell that later. We'll be able to see if that'll actually show up. All right, so I think we're good to go. This is our blink. Oh, of course not. Jeez, how could I forget? This is my favorite part of boards. You can start to add kind of artwork or fun little bits. I highly recommend this same kind of thing. So what we'll do here is on the back, I'm going to put my initials. So let's see, text tool. So I'm going to put CG. We're going to put that on the back side silk screen. We're going to display it as mirrored because it's on the back side. The text is actually kind of weird about that. It changed the text size a little bit. We're going to modify that. We'll say size in X is 0.60. Size in Y, we'll make it a little bit taller than it is wide, 0.08. Looks a little weird, but make that 0.7. There we go. So that's going to go on the back side. And then up here, I'm going to do two things. We could put in a decal, but that's actually a pretty advanced topic. If you're interested in that, you can check out Contextual Electronics. On the top, though, we're actually going to put it in the copper. So we're going to do two things. So we're going to call this Getting to Blinky. Actually, you know what? We'll just call it Blinky. Save these same kind of text parameters, 070 and then 08. And then the other thing here is that we're going to put it, so we're going to put it in the front side copper. This is on the top side of the board. Okay, we're going to do that. Oh, that didn't like that. What happened? I must hit escape. Shoot. Blinky, one more time, for good measure. So 0.07. Copper, good, 0.08. Oh, I know why. We're actually not showing. We must not be showing something right now. That's it. So we're actually not showing the top side copper. There it is. We put two of them in there. So let's Well, normally I would tell us to put copper underneath, and then if you want the copper to show through, what you do is you actually put the same layer in the solder mask, and actually it's a solder mask relief. So if you've ever looked at a green PCB before, all that green stuff on there is solder mask. It protects the solder from oxidation. So what we can do is actually relieve that stuff away and just have an empty space in certain areas. So what we can do is modify this, change it to the solder mask layer, front mask. There we go. So we move this over. Now we'll have copper showing through where the Blinky says. What if we have room for it? I think we do. Let's make that Getting to Blinky. One more thing, we need to make sure we didn't put two of those down. So remove filled zones. Yeah, it looks like it didn't go through. Okay, so that's good. We're going to edit text Getting to Blinky. Oh, a little too big. Now we need to make sure that we're not writing over anything else either. So one more time, let's edit that. And this is, you can skip this if you really want to. You can skip all this if you want to. There we go. Let's see how that looks. And we'll justify it just a little bit to the left. Style left. Okay. Didn't seem to like that, but all right. So if you want to see, just to verify what layer that's on, if we actually select the front mask, we can see that gets rid of some of that. All right. And of course, you know, there's a couple different pink layers here. We can change the color if we really want to. But we're okay with pink right now. All right. So if we redraw the layers here, redraw. Here we go. All the rat's nests are connected. Oh, we missed one here. What is that? That's the value, and that is now invisible. All right, and we'll be able to double check all that in the next video. All right, there we go. That's our Getting to Blinky board. Hope you like it. Hope it works. And thanks for watching.